Good morning, students. I am Dr. Gauri Patil, Assistant Professor at Department of Physics from Arts, Science and Commerce College, Ramanandanagar, Burli. Students, in today's lecture, we will discuss chapter from BSc second year, paper number 6, Wave and Optics. Chapter name is Wave Motion and Ultrasonic Waves. So, students, in previous lecture, we have discussed about the group velocity, phase velocity, and we also derived the expression for the transverse wave on the string. So dear students, now we will continue our lecture with some revision of previous lecture. So in last lecture we have discussed the phase velocity and group velocity. So students, what is mean by phase velocity and what is group velocity? We will move to the next slide. So students, phase velocity means the phase velocity of a wave. I will repeat you once again that phase velocity is the velocity of a single particle. Means we know that when any particle is moving, then a wave is associated with this particle, and this is called as the phase velocity, means the velocity of a single particle. And this phase velocity of a wave the rate at which the phase of the wave propagates in a space, which is called as a phase velocity. I will repeat once again. The phase velocity of a wave is the rate at which the phase of the wave propagates in the space. Okay, means this is the rate at which the wave propagates, and which is given by the formula, which formula? Vp is equal to omega by k. Phase velocity is given by the formula Vp is equal to omega by k, where omega is the angular frequency and the k is the wave number. Okay students, is that clear? What is Vp is represented by the phase velocity and which is given by the omega by k. Omega is angular frequency and k is the wave number. So if you consider any wave or any wave particle, if this is the wave, now I will draw, then you will imagine this. This is the particle and in which the wave is associated. Suppose this is the particle, and this particle or this wave having the equation which is represented by this equation, y is equal to a into sine of kx minus omega t. And if this velocity is constant, okay, then we put kx omega t minus is equal to what? 0. Then we get kx is equal to omega t, then x by t is equal to omega by t. So from this we have dx by dt, derivative of dx by dt, which is equal to Vp, and we can write Vp is equal to omega by k. So student, phase velocity is the velocity of single particle, single wave particle. Now we will discuss about the what is mean by group velocity. So dear students, group velocity, from this name I think you can imagine what is mean by group velocity. It is if there are more than two waves, then what happens? These two waves are getting interfered with each other, and because of that we get the packets of wave. Okay, wave packets, and these are represented by group velocity. So I will again I will explain again that what is mean by group velocity. Group velocity of a wave is the velocity with which the overall shape of the wave's amplitude, means if there are two waves and which are traveling in motion, and then again these waves are get superimposed with each other, then what happens? Then we get the wave packets, or we get the envelope or modulation of the wave. Okay, means inside this envelope there are the presence of these two or more than number of the waves are present which are inside this envelope, and which is presented by the group velocity, which is dw by dk, d omega by dk. So group velocity is the modulation or envelope of the wave which propagates through the space. So here students, as phase velocity is omega by k, and here in the group velocity this is the d omega by dk. So from these two condition, you can understand what is meaning of phase velocity and what is meaning of group velocity. Means in phase velocity there is a one single wave particle, okay, and in group velocity there are numbers of wave. So we can write like omega by k and d omega by dk. So group velocity is equal to phase velocity when the refractive index is constant. Means when refractive index is a constant, then and then only group velocity is equal to phase velocity. So dear student, now once again I will define what is a phase velocity in very simple language. Okay, we will again revise it. So phase velocity, as I said you before, that is the phase velocity, the velocity of a single wave is known as a phase velocity. Okay, phase velocity is the velocity of a single wave. Suppose if there is a one wave in which this particle is associated with this wave, the particle which is moving, and we know that whenever there is a motion of any particle, then there is a wave associated with it, and this is denoted by the wavelength of this wave is denoted by lambda is equal to h upon p, and where p is the momentum of this wave. So here the equation of this wave, which is y is equal to a sine of omega t minus kx. If this wave traveling with constant speed, then we can write omega t minus kx is equal to phi, which is constant. And if we differentiate this wave with respect to x, then what we will get? We will get omega dt minus k dx is equal to 0. Constant of differentiation 0. So we can write this omega dt minus kx is equal to k dx is equal to 0. So from this equation also we get dx by dt is equal to omega by k, and this is, we know dx by dt is what? Dx by dt is phase velocity. In previous lecture you cleared this. What is a Vp? Vp is dx by dt. So from this and this, what you get? Which condition you get? Vp is equal to omega by k, where k is equal to 2 pi upon lambda. K is wave number and omega is angular frequency. So dear student, this is the all information about the phase velocity, and always remember that phase velocity is the velocity of single wave. So now we will move towards the group velocity. Students, as we discussed in the last lecture, that whenever there are more than one wave or two or three waves which are interfere with each other, then what happens? The combination of this wave or interference of this wave is a what? The interference of this wave is in the type of envelope of modulated wave. Means here I will clear once again in very simple language that phase velocity is the velocity of single wave, and which is given by the formula lambda is equal to h by p, where h is a Planck's constant. This h is the Planck's constant, and this p is equal to, what is a p? Value of p is equal to mv. Okay, momentum. Means wavelength is inversely proportional to the velocity here, and as mass is increases, what? Lambda is decreases, and as wavelength is increases, mass is going on decreases. As wavelength is increases, velocity is going on decreasing. So this is the relation between the wavelength and the momentum. Now what we have discussed about the group velocity. Velocity of an envelope of a modulated wave. Means suppose there is a one wave, okay, there is a one wave which is traveling, and there is another wave which having different frequency than this first wave. Then what happens? These two waves are getting superimposed with each other. Then what happens? We get the envelope like this, okay, where there are wave which is inside this envelope. So what happens? The wave which is traveling with this envelope means this. The wave which is traveling with this envelope is group velocity, and the wave which is inside this envelope means this, which is traveling with the phase velocity. Okay, so students, I will repeat again. Here there is a first wave and there is a second wave. These two waves having the same these two waves having different frequencies, and when these two waves are getting interfere with each other, then we get the here like this envelope, and in this envelope there is one wave. The wave which is traveling with this envelope having the group velocity, and the wave which is traveling inside this envelope having the phase velocity. So dear student, this is the major difference between the group velocity and the phase velocity. Now students, in next slide we will discuss about the derivation of group velocity. So here, as I have discussed in the last slide, that what is a group velocity and phase velocity. So dear students, here there are two waves. Okay, first wave is this. Okay, here this is the first wave. Okay, and this is another wave. These two waves having same amplitude. Okay, these two waves having same amplitude. Amplitude means what? Here I will show you. In this wave, this region is called as the amplitude. Okay, so what happens here? This is the amplitude. These two waves means this and this. Look at carefully. These two waves having the same amplitude but different angular frequency and the wave vector. Okay, and these two waves are traveling. Then what happens? These two waves get interfere with each other or superimpose with each other, and when these two waves are superimposed with each other, then we get these wave packets. Okay, we get these wave packets. Okay, so first wave, which is represented by equation y1 is equal to a sine of omega 1 t minus k1x, where omega 1 k1 is the angular frequency and wave vector of first wave, and omega 2 and k2 is the angular frequency and the wave vector of the second wave. So here we get y1 is equal to a sine of omega 1 t minus k1x, while y2 is equal to a sine of omega 2 t minus k2x. So dear students, now these two waves are getting superimposed with each other. Then we can write this by equation y is equal to y1 plus y2. Okay, means when there is a formation of a wave packets. Okay, so this is representation of this wave packet, y is equal to y1 plus y2. Then what happens here? Here we will add this. Okay, we will add like this by making common a, and then sine of omega 1 t minus k1x, value of y1, and value of y2 sine of omega 2 t minus k2x. Here only we put a as a common from the y1 and y2. Then in here what we have done here, a and then 2 sine of, then just we sine of a minus b. What is the formula of sine of a minus b? No dear students, here what we have done here, sine of a plus sine of b. What is the mathematical formula for sine of a plus sine of b? 2 sine of a plus b upon 2 into cos of a minus b upon 2. So this formula we have used here. Sine of, remember once again I will tell you, sine of a plus sine of b is equal to 2 sine of a plus b upon 2 into cos of a minus b upon 2. So what here we have done, we put only here, instead of omega 1 t minus k1x, put a, and instead of omega 2 t minus k2x, we put b. So we get sine of a plus sine of b, and then we use sine of a plus b upon 2 into cos of a minus b upon 2. Then here we get this step. Then what we have done here, just put cos and sine for the t and x factor. Okay, just we separate from this. Okay, here cos omega t, omega 2t, just we put outside for the t and x, just for the cos and the same for the sine. Then what we have get here? What we have get here? Here we get the expression like this. Okay students, then here we write here like this: omega 1 minus omega 2 upon 2 minus k1 minus k2 upon 2 into x into sine of omega 1 plus omega 2 into t upon 2 minus k1 plus k2 upon 2 into x. So here just I will repeat, we just separate out cos and sine for the x and the t. Means here omega 1 minus omega 2 upon 2 t minus k1 minus k2 upon 2 into x. Same for the sine. So here what is omega 1 minus omega 2 and k1 minus k2 upon 2? So dear student, this value which is represented by delta omega, k1 minus k2 upon 2 is represented by delta k, and here omega 1 plus omega 2 upon 2 is omega and k1 plus k2 upon 2 is k. So just we write, instead of omega 1 minus omega 2 upon 2 by delta omega, k1 minus k2 upon 2 by delta k, omega 1 plus omega 2 upon 2 is by omega and k1 plus k2 upon 2 by k. And by putting all these in this equation, then we get finally 2a cos of delta omega t minus delta kx into sine of omega t minus kx. So dear students, here I will once again repeat. Finally, when you put value of delta omega, delta k, omega and k in this equation, you get this value. Okay, you get this step. Then here this equation represent two contents. First is the phase and second is the group. So the here this means the bracket or this cos function or this term with the cos which is represented by the group velocity, and this term with the sine represent the phase velocity. Means when we want to calculate group velocity, then we put first bracket is equal to constant, means cos term. Means if we put this delta omega t minus kx is equal to constant, and then we when differentiate with respect to x, then what we get? Delta omega into dt minus delta k dx, constant of differentiation 0. Then we get dx by dt upon d omega by dk is equal to vg. This is the group velocity. And dear student, when we want to calculate the value for the group phase velocity, then just like this we put omega t minus kx is equal to constant. If omega t, here second bracket with sine term, here what I told you before, the term which is with cos function represent group velocity, and the term which is with the sine function represent the phase velocity. So if we want to derive the relation between the phase velocity, then what you will do? You put sine omega t minus kx. Here I will write omega t minus kx is equal to constant. Once again I will, here you just put like this: omega t minus kx is equal to constant. Okay dear student, and then we put the differentiation of omega t minus kx. So what is the differentiation of omega t minus kx? Omega, what is the differentiation? Omega dt minus k dx is equal to 0. So we get dx by dt is equal to omega by k, and this is the relation, means here we get for dx by dt is equal to omega by k, and this is the relation for the phase velocity. Means for group velocity we get dx by dt is equal to d omega by dk, which is represented by Vg, and for phase velocity we get dx by dt is equal to omega by k. So student, this is the expression for the group velocity.